Hello everyone, welcome back to Civil Learning online YouTube channel, and today in this video I am going to discuss about the convolution theorem, which is very important in inverse Laplace transformation, as I have already discussed about its application. So in this lecture I am going to show you how to derive the convolution theorem. So without any further delay, let's get started. Here is the proof of convolution theorem, which states that if inverse Laplace transformation of f s bar equals to f t and inverse Laplace transformation of g s bar equals to gt, then inverse Laplace transformation of g bar s times f bar s equals to integration from 0 to t fu g t minus u du or integration of 0 to t gu f t minus u du. So whenever we are applying the convolution theorem, we have to choose them as gs and fs, and it will get converted into, when we apply the convolution theorem, it will get converted into fu times g t minus u, or we can also consider gu times ft minus u. We will be provided with two functions. You could have watched the application of convolution theorem in my example. If not, link is in the I section as well as in the description. You can watch the application of convolution theorem, and here is the proof of convolution theorem. So we have to convert that equation. We will be provided with two functions, so one will be considered as gu, another will be considered as ft minus u, or one will be considered as fu and another will be considered as gt minus u to solve according to convolution theorem. So let's proceed the proof now. Let us suppose that let phi t equals to, let's proceed with this term, this expression. So we have integration 0 to t g u times f t minus u du. So by definition of Laplace transformation, we know that Laplace transformation of phi t, it represents that phi is a function with t, function of in the form of t. So phi t equals to, as per the definition of Laplace transformation, we have integration 0 to infinity e to the power minus st times integration of 0 to t gu times f t minus u du times dt. Okay, so on doing one more step, what we can write it separately by doing the multiplication with e to the power minus st. So we have here integration of 0 to infinity, integration of 0 to t. So guys, you can see here we have du, and this integration is for in the form of u. So we will have here u equals to 0, and this is from the definition and this is the function. So let's close this, cover this. So we have integration 0 to infinity e to the power minus st times dt. So here it indicates that t equals to 0 to infinity. Okay, so we have here this integration is for t equals to 0 to infinity, and we have to cover this, and you can see that this integration is for function variable u. So we have u equals to 0 to u equals to t, and this is t equals to 0 to t equals to infinity. So now we have to rewrite it as e to the power minus st times g u times f t minus u du dt. So now guys, we got this, that Laplace transformation of phi t equals to integration of 0 t equals to 0 to infinity integration of u equals to 0 to u equals to t e to the power minus st gu times f t minus u du times dt. Let's put a bracket here. Yeah, we can put bracket here, and now we need to change the order of integration in order to prove the convolution theorem. So for that I will need to draw two graphs, and let's see how it is done. So guys, now let us draw a graph for t and u. So we have to draw a straight line here, and see if we plot this graph, then how it is going to be. We have to draw the graph for t and u. Okay, so what's next? See here, we have t equals to 0. So t equals to 0 means this line. Okay, t equals to 0 to t equals to infinity. So here it goes. Similarly, we have u equals to 0. So this line represents u equals to 0, or you can say that u equals to 0 is this origin. Here both are 0, t and u are 0, and this line is u equals to 0. Similarly, t equals to 0 is this point origin, and t equals to 0 is this line, as it is both 0. Now second is we have u equals to t. So u equals to t must be this line, like you have studied in graph, like this point could be 1 1 2 2. So t tu, another value of tu, like that. So this is t equals to u, and this, and if we consider a small strip of this area, this equation, then it is here. This is a small strip, area of a small strip between these limits, that is t equals to 0, t equals to infinity, u equals to 0, and u equals to t. Now what we need to do is we have to change its order. We have to change the order of limit. So how we are going to do this? See here, we have to draw one more graph, and we need to do this because we are going to change the order of integration. This is as per the theorem of convolution theorem. So let's change the order now. So again, everything is going to be same, all the notation. So we have this t equals to 0, this is t, and this is u, and this is t equals to 0, this is u equals to 0, and this line is going to be u equals to t. We have this u equals to t. Now what we have to change the order of this area. So this time we will draw horizontally in order to change the orientation. So if we change the orientation, now you can say that this will be t tends to infinity. Okay, t tends to infinity, and here we have u tends to infinity. Now let's write a line here, that is changing the order of integration. So now on changing the order of integration, we will have here integration for considering we have u equals to 0 to u equals to infinity, because we initially we had t equals to 0 to t equals to infinity. Now we are changing the order of integration, so we will take u instead of t. Okay, so we have u equals to 0 to u equals to infinity here. So u equals to 0 to u equals to infinity, this is small u. Okay, again next second thing, we have to take the order of t. So t equals to u, from t is beginning from here to infinity. So we have here t equals to u to t equals to infinity, and further we have e to the power minus st times gu times f t minus u du dt. Okay, so one more step. Now we have u equals to 0 to u equals to infinity. Let's bring gu outside. So we have gu times integration of t equals to u to t equals to infinity e to the power minus st times f t minus u dt times du dt times du. This is for t, because we have limit t, so we will take t inside and du. Now what we will do, let's put t minus u equals to x. So what we will have here, if we take the derivative of both sides, so we will have dt equals to dx. On doing the derivative of this term, so we will have dt equals to dx. So now we have supposed that t minus u equals to x, so we will have some variation in the limit also. So you can see here we have limit, we have in this figure we have limits as t equals to 0 to t tends to infinity, and another assumes limit was t equals to 0, sorry, u equals to 0 to u tends to infinity. Okay, so now what happens if we put t equals to 0 here, if we put t equals to 0, sorry, in this figure we have limit t equals to u and t tends to infinity, similarly u equals to 0 and u tends to infinity. If we substitute t equals to u here, so we will have x equals to 0, so we have another limits again here, and the limits are, if we have considered that t minus u equals to x, so now we have to check for the limit in terms of x. So if we put t equals to u here, so and we did derivative, on doing derivative we got dt equals to dx. Now we are calculating the limit because of the introduction of x, so we have to take t equals to u. So if we place t equals to u, then we have x equals to 0, and if we put u equals to 0, then we will have x equals to t, so x equals to t. So we will, sorry for this, we will change for t, and we have put first t equals to u, so and we got x equals to 0, and again we put t equals to infinity, so infinity minus something will again be infinity, so we have x tends to infinity. Now we will rewrite the equation. So our equation becomes Laplace transformation of phi t. Phi t represents a function which is equal to integration 0 to infinity g u, and start the bracket, integration of 0 to infinity. Now for x we will take for rewrite it for x, so e to the power minus s, st, so t is actually u plus x. Okay, so x plus u times f x, because f t minus u is x, so x, and dx times du. And you can see here this is the limit when we have x here, that is x equals to 0 and x equals to infinity, and we have limit for u also, that is u tends to 0 to u tends to infinity, gu and du here. So let's separate this exponential expression, that is integration 0 to infinity gu times integration of 0 to infinity and e to the power minus sx times e to the power minus su times fx dx and du. Now few more steps remaining. Now let's separate the term containing u and x at one place. So from the previous equation we have e to the power minus su times gu times du, and another expression for x is 0 to infinity e to the power minus sx times fx dx. What we did here, we have simply separated the term containing s and u. So here you can see this is for, this limit is for x, and this is x, this expression contains x, here x. So we have written these three at one place, and this is the limit for u, so gu and du, and e to the power minus su is written as at one place, so that we can do the integration. So if we have a closed loop to these two expressions, we can see that this expression and this expression are the definition of Laplace transformation, or we can say that Laplace transformation of phi t equals to g s times f s. This was as per the definition, or we can again rewrite it as phi t equals to inverse Laplace transformation of g s times f s. So we can say that integration of 0 to t f u g t minus u du equals to inverse Laplace transformation of g s times f s, hence proved. So I hope you understood this derivation. If you guys are wanting the application of this theorem, then I have already uploaded some example. We will continue with this lecture, that is Laplace transformation, and currently we are studying inverse Laplace transformation. So if you are new to this channel, then do subscribe the channel. See you in the next video. Till then, stay safe and take care of yourself.